We, the students of Gokaraju Rangaraju Institute of Engineering and Technology, belonging to Electronics and Communication Engineering, present you our final year project. The name of our project is Speech Recognition using Time Domain Analysis on DSK-6113 kit in Code Composer Studio. Speech recognition is the process by which the computer identifies spoken words. Basically, it means talking to your computer and having it correctly recognize what you are saying. This is the TMS 320 C6113 DSP kit that we are working upon. It has 512 kilobytes of flash memory and 16 megabytes of SD RAM. It works at 225 MHz clock. It has a 32-bit stereo codec ASC23 for input and output that provides ADC and DAC. It has basically 4 input and output ports. They are headphone, line out, line in, mic in. In our project, we use only 2 of these ports. Mic in port to connect the microphone set through which we give the voice input, and headphone port through which headphones are connected to hear the output. Let us now see the demonstration of the project. Before working with CCstudio, we have to run the DSK-6113 utility diagnostic test. Once the test is passed, we have to open the CCstudio icon. Our project basically consists of 4 modules. The first one is to store the granted word. The window you are seeing is representing the code. Once this code is compiled and loaded, we have to utter the word granted to store it and keep it in certain portion of the memory. The uttered word is also heard through headphones. Granted. Now, in the second module, we store the denied word in the same way. Denied. The main purpose of using these 2 modules is to confirm if the speech has been matched or not. If a match occurs, then the word granted is heard, else denied is heard. Next module of our project is the training phase where a word to be matched is stored. Since our project is an isolated word recognition, we recommend you to utter a single word. Once we load the program, we need to utter the word which can be heard back to the headphone. Hello. The basic process starts with silence detection, which determines when the user has actually started uttering the word. In the next step, the voice input undergoes windowing. For this, we use Hamming windows which eliminate the signal discontinuities at the beginning and ending. Then, Fourier transform is applied to the windowed signal to obtain the short time Fourier transform spectrum. The spectrum of a segment under a window for a particular word would always peak around the same frequency. This is called as dominant frequency, which is the key to our project. This dominant frequencies obtained for each of the 12 windows are stored in the training phase together, called as feature vectors. Here, D1 represents the values of the dominant frequencies for the just uttered word hello. The final phase is the testing phase. In this phase, a word is uttered. If this word matches with the same as that in the training phase, then we hear granted word as the output through the headphone. Hello. Since the audio output through headphones cannot be shown on the video, we are showing you the values of the 12 feature vectors of both training and testing phase. D1 here represents vectors from the training phase, while D represents the vectors from the testing phase. If 7 or more vectors have a difference of less than 10 amongst them, it means both the signals are matched, else they're not. What you see now on the screen is for the matched word. Now let us see the values of the vectors for totally 2 different unmatched words such as hello and goodbye. These are some of the main applications of our speech recognition system.